All right, and now we prove the inductive step. Now remember that these are the assumptions. These are the things that we get to assume. We get to assume that, we get to assume that. We want to show P of k. So we get to assume P of k. We want to show P of k plus 1. And we also get the additional assumption, because it was stated in the problem, that our function has this interesting additive property, f of a plus b is f of a plus f of b. And you can do that for any numbers that are in the domain. Any two numbers, a and b, of the domain, you can do this too. All right, so before we get going, let's do a little scratch work. So what I would do is I would first write out something like, let's put this over here. Let's say f of, so you write out what you want to show. F of k plus 1 x equals k plus 1 f of x. Then you say, okay. Then in the scratch work, you do kind of what you can't do in a proof. You can't assume that these things are equal, right? We're trying to prove that these are equal. We can't assume they're equal. But here in the scratch work over off to the side, right, we're going to just look at what happens if they are equal. Okay, well, if they are equal, then what could we do to them? Well, let's see. We could distribute that x. So now I'm going to distribute that x inside the f of part. So k plus 1 times x is the same as kx plus x. And I'm also going to distribute over here on the right-hand side. K plus 1 times f of x is k f of x plus f of x. So right there, all I've done so far is just use the distributive property. I haven't used either of the assumptions yet. So let's see, how could I use these assumptions, right? Well, let's see, this first one, it breaks things up, right? So we could break this up right here into kx plus f of x all right. And so then now we have, let's see, k f of x plus f of x. And so now we've whittled things down, right? This is where we want to get to. This was just algebraic manipulation, so we could definitely get from here, from this second line to the first, with just doing the distributive property in reverse, so that's okay. Now getting to this third line, right, we used this first property here, okay? Now, see, what we want to prove is that they're equal, right? We want to prove that. We want to prove that they're equal. If we can prove this, if we can prove this equality that I have with the arrow here, this one right there, if we can prove that equality, then we'll be done, because we can, through distributive property, we can go back up on this side, and through this property and distributive property, we can go back up on this side. So we really just want this right here. So now you think to yourself, okay, what haven't I used yet? I haven't used the inductive assumption, right? The inductive assumption tells me that this is equal to that, right? And other than that, I just have the same thing on both sides, right? So it's got it. So that's how we're going to do it. And what I want you to see is that the left-hand side equals right-hand side proof will start here, and it will go like that. Right, so over here on the side was, with the scratch work, this was our sort of mapping out our mental, or it was like our mental map of how this is going to go. All right, so the left-hand side of P of k plus 1 is f of k plus 1 x, which is f of kx plus x, which is f of kx plus f of x. So let's see, right? Started first we were here. This is that first thing there, then there, then there. That's that. Now we're going to go to this thing here. Let's see, how do we get here? Remember, we use the inductive assumption, P of k. Right, P of k tells you that f of kx is k f of x. Definitely need a justification there. That justification we could put in as P of k. Now using the distributive property, this is just k plus 1 f of x. That's the right-hand side. Now I think there needs to be definitely a justification for this second line here. And I think a perfectly good justification for that is just to list the property you used. F of a plus b is equal to f of a plus f of b. Oh boy, now I'm worried. I'm not going to have enough room, and I'm going to run into those little papers over there on the side, and it's going to take me to that paper. Ah! The objective hazards of a math teacher. Okay. All right, there we go.